Hello everyone. Welcome back to machine learning sessions. In this session, let us learn about instance-based learning. So this instance-based learning contrasts to the earlier learning methods what we have learned. Here, this is used to approximate either a real valued or a discrete valued target functions. So far, we worked out with only discrete valued target functions. Here, this instance-based learning can work with both real valued as well as discrete valued target functions. And also, the difference between the earlier learning and this instance-based learning is, earlier we have learned the target function. So the target function is well trained and it is ready to classify the new instance based on the past data, whatever it has. But here, whenever we are supplying the training examples, those training examples will be stored. Here, no learning will happen. Simply, the learning algorithm, it will store the training examples. And whenever a new example is given for classification, then at that time, whatever training instances are stored, they will be analyzed. So only we call this as a lazy learning method. The examples for these are KNN and locally weighted regression. When we go through the examples, you will be more clear why we are calling it as a lazy learning method. Let us get into the details. So the first example that we are observing is the K nearest neighbor learning. Okay, so this is the most basic instance-based method. So basic one it is. And here, all instances corresponds to the points in the n-dimensional space. So this you can also take it as the instance space. You can take it as r to the power of n. You can just represent it like this. A real valued value r to the power of n. So this is an n-dimensional space. And here, the distance measure k nearest neighbor. So how will we identify k nearest neighbors is based on the distance measure. So for distance, actually various measures are there, like Euclidean distance is there, Manhattan distance is there. But here we are preferring Euclidean distance because the data set what we are taking, it is a very smaller one. So and also we are taking the data set as a binary one. Okay. Suppose if your data set is very large with very like n number of features, so then you can go for the other distance calculations. But here for our training purpose, we are taking very a simple one. So we are taking only Euclidean distance. Here, an instance x is described by the feature vector a1 of x, a2 of x, so on up to an of x. For example, if I take the value of rth attribute of an instance, okay. So here this instance is containing 1 to n attributes. Similarly, for the same instance, if I want to know the rth attribute, how can I represent that? I can represent that as ar of x, right? So this is my rth attribute. A1 of x is my first attribute, A2 of x is my second attribute, like that, An of x is my nth attribute. So now what I want my rth attribute. So I can represent it as AR of x. So now, in order to know the distance between two instances xi and xj, we can represent that as d of xi comma xj. So to calculate this, we can use the formula square root of sigma I is equals to, or we want to calculate the rth instance, right? So let us take r as I to j, or let's take it as r is equals to 1 to m. So here this AR of x, here x is xi comma xj. So we are measuring the distance between these two. AR of xi minus AR of xj. possible. We just want to know the distance between these two values. So first let us see the KNN algorithm for the discrete valued target function. Later on we will see for the real valued target function as well. First let us see for discrete valued target function. So here the algorithm contains two parts, the training part as well as the classification part. So in the training algorithm, for each training example, x comma f of x. Here x is the instance, f of x is the target function. Okay, so whenever you have an example like this, add the example to the list of training examples. Don't do anything, no calculation is required, nothing. Just simply add it to the training examples. Now comes the classification algorithm. So here, given an instance x cube. So this is the new instance that is to be classified. Okay, so now let x1, x2, xk denote the k instances from the training examples. So now already we have saved the training examples, right? So from these training examples, we are retrieving only k instances. Okay, that are nearest to x cube. So now we will be returning a target function f cap of x cube, which is R max of V belongs to capital V. So these are the various possible values where sigma is ranging from 1 to k, though of V comma f of xi. So V is the value that we are taking from this capital V, and f of xi is the result of the target function. And after computing this, we are comparing. So dou of a comma v. So here a is your v and f of xi is treated as p. So now if the values of these two, if a is equals to b, both are giving the same response, then we take the result as 1. Otherwise, we take it as 0. Let's work with this algorithm with the help of an example. This is the example that I am taking. So here my example is containing 4 attributes. Okay. So this is my x1, x1, x2, x3, and this is my target function, the class of sport. So always it is represented as f of x. So this is my target function. So now we are using Euclidean distance for the distance calculation, and let's take a new instance. Okay, so here the new instance is Ria. Age is given as 5 and k value is taken as 3. Okay, so in most of the cases this k value is specified. Otherwise, usually how we take this k value is square root of the number of instances. So here we have almost 9 instances. So square root of 9. Suppose if you have 10 or 11, some odd number. So in that case, nearest root value you can take. Okay, suppose if I have 11 instances also, square root of 11 exactly I cannot find out. So square root of 9 I can take, and I can assume an k value of 3. Okay, but here in this example, k value is specified. So let's take the same k value. Let me show you one calculation of how to calculate the Euclidean distance. Okay, so it is x. Previously we have seen the formula x or AR of xi minus xj whole square, right? So here I have 2 instances. Here I have 2 attributes, not a single one. So here only the numerical values we are considering, age and gender. The first one is just the name. Based on name, I cannot classify anything. Okay. And here my target class is either a football or a cricket. So here you can see a binary representation here, or a 2-valued target class you can see here. And since x2 and x3 are the determining factors based on the age and gender, the taste of a person or the game that he is interested in is decided. So we are considering only these 2 instances. So you should be clear with this. Okay, so now this is our target instance, right? So Ria, from the name, we can take it as a female. And here the gender. So we are not representing it as male or female. Okay. Male is indicated as 0. Female is indicated as 1. Okay. Sorry, for the first one. Okay. So instead of changing the data values and all, let me change the name itself. So let me take it as Ajit. The name itself I am changing. I want to take it as a male. So because I have already computed the values. Okay. So age is 32, gender is male. Okay, so 1 is indicating female, 0 is indicating male. So the game that he is interested in is football. So now I want to, Ria is female. So the gender of this becomes a value of 1. So to calculate the distance, we are using the formula age 2 minus age 1 whole square plus gender 2 minus gender 1. So if I have a single attribute for this instance, so then I have indicated it as AR of xi minus AR of xj whole square. If I have a single instance. But here what I have one new instance with the help of which this new instance has to be classified with the help of the existing data. So whenever I have this information as per our algorithm, let me go back one step. I'll just show you. Yeah. So here in this training algorithm, okay. So here x is my instance, f of xi is my target. So in my example, what do I have? I have x1, x2, x3 followed by my target f of x. Okay. So that is name. I have age, I have, then gender I have, followed by this, I have the class of sport. Okay. So now whenever I have a training examples like this, what I will do simply, I will add this example to the training examples list and I have the database ready. So now when I have the new instance XQ, that is Ria, the name is Ria. Okay. So from the name, we are taking it as female. So indicated with 1 and age is given as 13. 13 or 5. Exactly. Okay. So age is 5. So now I have to classify this new instance. Okay. So what is my K value? My K value is given as 3. So I will take only 3 instances from the training example, which are nearest to XQ. Okay. So to know which are nearest, I have to use the Euclidean distance. Yeah, let's calculate that. Okay, so this is the formula for calculating the Euclidean distance. So now, age 1, I have taken as 5. Age 2, I have taken from the data set, that is 32. 5 minus 32 whole square plus gender 2. It is female 1 minus 0 whole square. So you can take either way also. Either you can take these as age 1 and this you can take as age 2. Okay, so that is of your choice. You can take either way. Because we have a square, it doesn't make much difference. So actually, this is from the simple line, the simple distance calculation. So that is usually we will calculate x1 minus x2 whole square plus y1 minus y2 whole square, right? Using Pythagorean theorem. So whenever you want to find out the hypotenuse, we use this formula, right? So in the same way, here also we are using the similar formula for the Euclidean distance. Okay, if you simplify, we are getting a value of 27.02. Okay, so similarly, you have to calculate for all other points as well. For example, if you take the second one, that is Madhu, gender is male again. So now how will we calculate the distance? Distance D is equals to square root of 5 minus 40 whole square plus 1 minus gender, 1 minus 0 whole square. So you have to simplify this. Similarly, you have to calculate for all other examples. So here I have calculated and I tabulated the values. Okay, so these are the values that we have obtained. So now the K value is given as 3. So now you should take this value as sorted data. So as per that, the first smallest value that we are getting is 9, then 10, followed by this, I have 3. So similarly, you can just number all other as well. Okay. So here my K value is 3. 3 nearest neighbors only I want. Okay. So whichever distance is very less, so that I am considering as my nearest neighbor. So as per that, this 9, 10 and 11. So these are the closest points. Okay. So what is the class house code or what is the target value that is given by this? Okay. So 9 is telling cricket. 11 is telling cricket. Okay. So here I should make a small correction. In the example data set, I have taken this as football. So 2 is telling the target value as football. So here, two approaches can be followed. Either a distance measure can be used or majority voting can be used. So here we are using the majority voting. So what does the majority tells us? So majority tells that the target class is cricket. So I can directly classify this as cricket. But as per our algorithm also, let's see what was the formula that we have. Argmax of V belongs to capital V. So what were the possible values for the target instance? So the possible values are either you have football or cricket. The V values that we have are these two. So now for these two values, we have to take V comma f of xi. And then based on that, if both are same, we will take the value as 1. Otherwise, we'll take it as 0. Let's do that. So now, let us first take the value of V as football. Okay. So we have taken the closest to 3. Okay. So based on the distance, we have taken 9 as 1, the distance 10 as 2, the distance 11 as 3. Okay. So now the first value that we are taking as football. And for this, the first f of xi value what I have is cricket. Next, do of. Again, we are working with football. K value is 3. So 3 points I am taking. Next to 2. So this is football. The next value is do of football, comma, the third one. So it is taken as cricket. Okay. So this is done for one V value. Let's do the same for the other V as well. And let's take the maximum of these two. So that is the next V that we are taking as cricket. So it is cricket, comma, the first f of xi value with distance 1. It is cricket. Next, our V value now is cricket. This is not going to change. Only our target function is going to change. Okay. So with the second distance, the target function value is football. Next, cricket, comma. For the third, the target function value is cricket itself. So this is for the second V value. So the first V value is football. The second V value is cricket. So based on the first V value, we have taken it as football, comma cricket, football, comma football, football, comma cricket. Okay. So now the dou function we have to evaluate, right? So this is A and this is B. So whenever A is equals to B, the value of this dou becomes 1. Otherwise, it becomes 0, right? So based on that, let me change my ink color. So based on that, my argmax has to take the maximum one. So the dou value of this is 0 because A is not equals to B. In the second case, A is equals to B. So the dou value is 1. I have to take a summation. So let me write a plus directly here. Next, football, comma cricket, A is not equals to B. So it becomes 0. Next, dou of cricket, comma cricket, it is same. So we'll mark it as 1. Cricket, comma football different. So the dou value is 0. Cricket, comma cricket, A is equals to B. So the dou value is 1. So now if I see, this will equate me to a value of 1. This will give us a value of 2. So 2 is the maximum one. So what is my V value? I got a V value of 2 for cricket. So finally, argmax is taken as argmax and the value of this is taken as 2. So 2 is for the value V as cricket. So finally, this new instance will be classified as the target class of this new instance will be classified as cricket. So this is how KNN algorithm will work for discrete value target function. So in the next session, we will see how KNN will work for real value target function. Hope you follow. If you have any queries, please let me know in the comment section. Thank you. If you like the video, please do subscribe and share it with all those who need it. Thank you.